Hey guys, welcome back to my channel. Today, it's a continuation of the challenge that we have temporarily stopped. This is not exactly coding. Um, Before this, we were taking an approach of solving leak code, specifically in Python. But for today, I wanted to talk about virtualization, containerization, and um, the technologies involved in it, such as VM, Kubernetes, or uh, or Docker, even Jenkins, if we have time to touch upon it. This is because I've had interviews for platform engineering roles, junior, of course. I didn't have any experience before that, and um, I've had requests to prepare a presentation for those. They wanted to test my learning ability or something. So I prepared one of them, and I thought it would be also good to share one of those in my YouTube channels because while I was researching for those two topics, I realized that um, not all the sites uh, mainly like Reddit's, for instance, they just want to just show off their knowledge. They don't really specifically define the definitions and um, clearly explain the differences. I think they are very lacking on those, and I was only able to find the clearer versions on official websites of those two applications like Dockers or Atlassian. But anyways, um, without further ado, let's start. So, what is a virtualization? Before diving into VM or containers, virtualization is basically creating virtual versions of physical resources like servers or storage devices or operating systems. Um, Before, we were businesses were setting up multiple of single servers to incorporate applications and storage and configuration. So each servers had to have their own operating system, own server, uh, own application, and series of other stuff to support that application. And uh, this would be copied. This kind of servers would exist in multiple numbers, and in order to uh, maintain this structure, you would have to spend so much of that money, and you would have to have lots of physical slots as well, size, I mean, and the security problems needed to secure that place as well. Uh, Instead, there were new technology developed in a sense of virtualization. So this allows multiple operating systems to coexist on a single physical computer, like in this sense, physical server. So instead of this, this became one server. So I'm just drawing as one server, but in reality, there could be multiple servers. But for the sake of this explanation, uh, let's just imagine that we have one server. And then in this one server, they would have one host operating system instead of multiple host operating systems existing on multiple servers, physical servers. And in this one host operating system, on top of this, um, there will be a hypervisor that orchestrates the different VMs. So in this case, this is called VMs, virtual machine. So instead of physical machine, it is virtually uh, creating and splitting resources to multiple operating systems. Right now, we have one host operating systems, but on top of this hypervisor, so this is a hypervisor that is an application that shares resources between multiple operating systems that is built on top of it. So this could be Linux, and this could be Unix, and this could be Mac OS. So yeah, it's just running simultaneously. This Linux machine could run, for instance, an email. This Unix machine could run a database, and this Mac OS uh, could run a game, for instance. And it's all running on one big host operating system. It could be anything also, and one hypervisor to orchestrate those operating systems. So a benefit of this is that I've written it. So um, is like I said, um, you can have multiple servers running on a single physical computer. So um, there's lots of flexibility involved, and there's also efficiency. Um, uh, yeah, but there are also disadvantages, like from this text file that I've made before. Uh, it can consume a lot of disk space. This is, of course, compared to the containers that we're going to explore right after. It can consume a lot of RAM and CPU power because, of course, there's a lot of operating systems, multiple operating systems running on one single physical computer. And it is also very slow to start up. Yeah, it can take minutes to start up. Um, I think one of the operating system that I used before is Xubuntu. Um, yeah, that's one type of VM. So with that said, uh, while it offers um, this flexibility and usability, there are disadvantages to it. And another uh, type of way to manage these multiple operating systems and running multiple application is by using the containerization. So what is containerization? Um, Containerization is basically container. Imagine there's lots of boats, and then you're putting multiple people into it. This multiple people could be applications, configuration to support those application, uh, database file to support application, so on and so forth. So these one boat, so this one container uh, contains all the necessary resources to um, deploy one to run one application on another PC or so ever. So if you have this container, if you just have this container, you can use this container on different PCs or different physical machines to run the same software. So it's like a GIF wrap, and you're wrapping a GIF of an application, and there are multiple applications, and this allows to even further reduce the number of resources, reduce the load. One second. So this, so there could be one physical hardware as well. On top of this, this could be a host operating system. And then now there is a container engine, what they call as container engine. Uh, this could be Kubernetes, for instance. And on top of this, there could be different containers instead of the different operating systems that we saw in VMs. And in this, uh, these applications in containers. These are all containers, and then inside there's an application. Share one same host operating system. So, in a sense, operating system is what takes the disk space and CPUs, RAMs the most. So that's why in a different context, in the previous VM that we saw, there were at least four OSs being used, one host and three guest OSs on top of that being run. On in comparison, containerization using containers allows um, different containers on top of the same OS. So they use the same OS. So there's, uh, in essence, less file size. Also, it's very lightweight. It's really fast compared to the VMs. While VMs take minutes, containers will take milliseconds to boot up. But on the other hand, it has also its disadvantages that it can only run on one operating system. And if this operating system crashes, all can go down. But uh, but yeah, but it is super beneficial, and that's why uh, lots of application companies use these kind of software. They use Kubernetes. So here comes a Kubernetes is Jenkins uh, and what was the other one? Kubernetes Jenkins and Kubernetes Jenkins and the one that I was talking about this whole time. Jenkins and Docker. Yes. So Kubernetes. So basically this is like a whole big platform. And then inside there's Jenkins. No, I mean, yeah, Jenkins and Docker. And Docker is the main. And Docker is, so if we start from Kubernetes, Kubernetes is a container orchestration platform. So it analyzes the resource requirements of each container. So there could be containers, and it allocates the necessary resources to those containers. And also at the same time, because it's a cloud native application, it balances the workload among all containers within this Kubernetes ecosystem, and then it maximizes the resource utilization. So within that millisecond of uh, containers being used, it even more maximize the efficient usage of these resources by balancing the workload. In AWS sense, they call it as a load balancing, right? So it is like a big brother. It looks upon all the processes happening within the context of containerization, automatically managing, creating, orchestrating multiple containers across numerous hosts. Um, and yeah, and Docker is used to create those containers, while Kubernetes is um, used to orchestrate where to put more containers and where to put no where to put more power to more where to put more usage of CPU to one container and where to reduce uh, in opposition to another container. Docker is like one of the container application to make, use, and deploy those containers. So you can use Kubernetes without a Docker, but you cannot use Docker without Kubernetes. Um, so in a sense, mm, yeah. And Jenkins, simply saying it's like automatically managing that Docker. So incorporates the CI/CD pipeline. So what is a CI/CD pipeline? It's a continuous improvement, continuous delivery. So it automatically deploys those Docker containers. Um, so it is kind of a additives that is being used alongside Docker in a sense. And yeah, this I would have to learn more Dockers and Jenkins, but in a sense, that is a definition, and that's a main definition. Kubernetes, the platform, Docker used to create those containers and deploy them. Jenkins use on top of Docker in order to create a flow of making containers. Um, like I mentioned load balancing. Kubernetes involves this process called horizontal scaling. So you just need to deploy more containers across a cluster of machines to meet more demand. Um, on top of load balancing, it can also include abilities like service recovery. So from disaster, um, if one of the system that is being deployed on top of Kubernetes, one of the containers crashes, it doesn't affect another one, um, because, like I said before, that this containers can in this container system, it can only run one operating system at the bottom, so one host operating system. So if this host operating system crashes, all go down. But Kubernetes try to minimize this risk by including service discovery, service recovery, and self-healing. Uh, in a sense, this also allows to handle the incoming requests. For instance, if there's too much number of requests incoming, then it will shut down. It will limit it. And to sum it all up, VMs and no, containerization is cheaper. That's another advantage. It's cheaper than the VM uh, because you'll need to install operating system for each VM, right? Linux, Unix, whatever it is. Configure network settings of each of them and set up any dependencies needed. And this could be really time consuming. And if you're not like an expert in this field, um, and you would obviously need more resources since it's a resource intensive process. Kubernetes, on the other hand, is um, it's much not I wouldn't say it's simpler, but uh, it is more portable. It is more portable because containers encapsulate an application and its dependencies, and you can deploy them easily, independent of the underlying infrastructure, like in VMs. Um, and Kubernetes will automatically configure the state of the application, whether that will be um, uh, uh, whether the underlying file would be written in JSON file or YAML file. It will automatically configure the container to match the specification. Um, and yeah, while learning all of those, I found it really interesting, and I thought that it would be really nice to have an opportunity to use all these software, but I will know once I progress to the next round. But anyways, um, this was um, part of my research that I've done. Probably there's a lot more people who knows better than me. Um, I'm just diving my feet, putting my feet into the field. But anyways, it was very interesting. If you have any comments or any advices, let me know in the comments below. And thank you for watching. I'll see you guys probably um, soon or later, probably with SQL, because I feel like Python, SQL, um, two languages that you really have to excel in order to be competitive in the coding test scene. But that's for later times. I'll see you guys in the next video.